welcome back to the classes by Mrs. Monisha. We are back again with the continuation lesson square and square roots. Today we are going to learn to find the square root of a number using the division method. In the previous video we have already learned about how to find the square root using prime factorization method. If you have not gone through the video, please go through so that both the methods are very well known to you and you find it easier to find the square roots using any one of the methods. So we'll start with the division method here. So using division method, we are going to find the square root of 729. So the method is very simple. If you understand the method logically and systematically, then for any given number which is a perfect square, you can find out its square root. Say 729. First you will put the division symbol and then start pairing the numbers. You will start pairing numbers. How do you pair numbers? From the right hand side, that is from the units place, you will start pairing the number. That is units and tens become one pair. Next we have 7. 7 is a number without any pair. So you can keep a bar over the 7. So for each pair you have to place a bar. Okay, but 7 is a single digit. It has no other pair or no other digit to be paired with. So you can keep 7 as a pair. So each pair of digits and the remaining digit that has been there in this case we have one digit in the first place. So these are called the periods. Each of them are periods. Okay. Now how to go ahead with the division? Now your first number that you will start working it is with 7. So you can think 7. Now tell me a perfect square which is either equal to 7 or less than 7. So in the series of perfect squares, it is 1, 4, 9, 16 and so on. So which number is a perfect square which is lesser than 7 or equal to 7? Equal to 7 it is not possible. We can see there is no number which is a perfect square and equal to 7. But we can see 4 is a perfect number which is perfect square which is less than 7. So how do we obtain the 4? 2 2s are 7. So above each pair you will write its quotient. So 2 2s are 4, not 7, 4. Now take the subtraction. See 3. Now you will bring down the quotient. Bring down the remaining dividend over here. So this is the new dividend, 329. All right. Now what is the quotient here? 2. Now double that. Double of 2 is 4. Keep some space over here and then double the digit and place it over here. Now what do we place over here? Now you have to think of a digit which will be placed here as well as the same digit will be placed here, so that when we find the product of this into this, we get a number which is either closer to this or this. I repeat, once you double this quotient, place it here with some space, because this space is kept for entering a digit over here. Now whatever digit you enter over here, with the same digit you will be entering over here in the new quotients place. In the second period, for the second period, the same digit has to be entered here, so that when you find the product of this as a number into this is the new divisor. This new divisor into this quotient here will either give you this result or a number lesser than that. So what should be placed over here? So 40. Tell me what you should place over here. 47 if I place over there into 7. How do I decide whether I will place 47 or 42 or what? You see, whatever number is to be placed over here, the same number will go over here. So the units place here when multiplied this should be giving me a 9 over here. So what numbers when multiplied give 9? Either you will get 3 into 3 9 or 7 into 7 will give you a 49. So the 9 in the units place. So either 3s or 9s when they are squared, they will give you 9s in the units place. So 7 into 7, 9, 32. So here we will put 7. Here also 7. So 47 into 7 is 329. So the remainder is 0. So once the remainder is 0, that means you have got the square root. That is, when the periods are all exhausted, that means you have found out the square root. So the square root of 729 is equal to 27. Alright, I repeat once again. Whatever number has been given to you, put that within the division symbol, and then you start pairing the digits from the right. So the units and the tens is one pair. Next goes the hundreds and the thousands and so on. So if you have a single digit over here which is having no pair, then you put that as a single digit, and each of these pairs along with the single digit, if there is any, then these will form different periods. Okay, so from here only you can get one concept, that how many digits can your given number have in the square root. So if the number of digits in the square is n, say n is even, so for each for n digits, how many pairs are we going to get? N by 2 pairs. Okay, suppose there are 4 numbers. 4 numbered means when you are pairing them, you will get 2 pairs. So for each, that's why I told you above each pair write its quotient. So for each pair you are getting one digit of the quotient, that is 1 digit of the square root you are getting. The number here is the square root. So for each pair you are having 1 digit of the square root. So that means if your n is even, that means you have n by 2 pairs over there. That means these many digits you have in the square root. Alright. And if your n is odd, like in this case, so 1, 2, 3, there are 3 digits, n is odd. So n plus 1 by 2. Why did we do n plus 1? Because this single digit will also work as a pair. I mean, you are considering it also as a period. Each period is made up of 2 digits, giving you 2 digits each period. So, but here, because the last digit here while pairing, we saw that this is the last digit which is having no pair. So this single digit was treated as a period. So that means how many periods you are getting. So actually you are counting how many periods rather than pairs. So here single digit also is forming a pair, forming a period. So for 3 digits, what would be, suppose 3, so 3 plus 1 by 2, that is 4 by 2, that is 2. So see, 2 digits we got over here. So for odd, you will get n plus 1 by 2. So suppose if your number of digits in the square is 5, so your square root will have n plus 1 by 2, that is 5 plus 1 by 2, that is 3. 3 digits in the square root. If it is having 8 digits in the square, then the square root will have 4 digits, because 8 digits will give you 4 periods. So for each period you will have 1 digit in the square root. That means there are 4 digits in the square root. And suppose you have 9 over here in this, suppose 9 or let's say 7. If you have 7, then 7 digits will also give you how many periods? It will give you 4 periods, because the first digit from this side, from the left side the first digit, also from the right side when you are pairing the last digit here, this will have a single digit, but still it will form a period. So that's why for each period, so how many periods you are having over there? So 7 plus 1 by 2. So 8 by 2, that is 4. That means your 8 digits will also give you 4 digits in the square root, and a number with 7 digits in the square will also give you 4 digits in its square root. So counting the number of digits is quite clear, I suppose. Okay. So repeating this again. So suppose 7. Once we made the periods, we saw that 7 was the single digit over here. So you have to find a perfect square which is either lesser than this or equal to this. So since 7 is not a perfect square, so a perfect square that is less than 7 is 4. So how do we obtain 4? 2 square. So 2 2s are 4. Alright. When you subtract, you are getting a remainder 3. Now bring down the next period or the next pair from the dividend and place it over here and make it the new dividend. Now whatever quotient you get over here, double that. So 2 square is 4. We got down the 4 over here. Okay. 2 square 4. Now leave some space over here to enter a digit. Now what digit you will enter? Whatever digit you enter over here, the same digit has to be entered here above the period for the next digit of the square root. Also keeping in mind that this as a number this is the new divisor. The new divisor multiplied with the new quotient should be giving you this dividend. Alright. So how do we decide what number I will put over here? You check the last digit here in the new dividend. It is 9. So you have to find out what number multiplied to itself brings a 9 in the units place. Either numbers having 3's in the units place when multiplied, they bring a 9 in the units place in the product, or numbers having 7 in the units place when multiplied will bring a 9 in the units place. So 43, we could have tried with 43 into 3, 9 and 129, not enough. Next I tried with 47 into 7. Here you might give might give trials to check the number. So this was 329. So I placed 7 and got the answer. Square root of 729 is 27. Alright. Going to the next sum. 7056. So here we have 4 digits in the square. So you can see that the number of periods here are 2. Now 70. Which number is closer to 70? Which perfect square? 64. Because 70 is not a perfect square, but a perfect square that is closer to 70 is 64. So 8 8s are 64. Minus 6 is the remainder. Now bring down the next pair. Okay. Now what I said? Double of this. 8 square is 16. Now place something over here and something over here. Same digit. So that we get a 656. Alright. Now which digits placed in the units place when multiplied with the same digit gives a 6 over here? Either 4's, because 4 4s are 16. So either 4's you can place, or you can place 6's over here. Okay. So either a 4 or a 6. Either of these two you can place. So let's see if I put 164 into 4. See, easily we got in the first chance. 164 into 4. So here we will put, so 164 into 4 is 656. Remainder is 0. So square root of 7056 is 84. So this is less time taking than prime factorization method. Okay. So this will be of much more help to you. Okay. So the square root of 7056 is 84. Now the third question is there already on the board. Take 15 seconds and finish it up quickly. Quickly. 5, 6, 9, 6. Find the square root. Quickly. Come on. Okay, let's check those who have done they are right or wrong. So we can see once we start putting them in the pairs and bars over each pair, this is one period, another period, this is a single digit. Okay, so this, for this which is a perfect square, that is less than 5, that is 4. So 2 2s are 4. Remainder 1. Bring down the pair, 156. Now 2 square is 4. Now we'll check for a number which when placed over here, also multiplied here with the also put over here and multiplied, we get a number either equal to 156 or close to 156. So what number we shall place over there? That is, let us check. So 43 if I place. Now see, 6 means your first thing that will be coming in your mind is putting 4 and 4. So 16, 176. Going beyond this. So go for a number lesser than this. 3, 3. 129. Okay. We have no other option but to take this. So 3, 3. 129. So this is 7, 27. Now 27 means now bring down the next pair. Okay. Now for the next pair, now you will square up this 23. You will square up 23. Now don't square 9, only 3 and bring a 9. No, the new quotient is 23. Whatever is the new quotient has to be multiplied. So 23 means 46. Double of 23 is 46. Now what number should be brought down over here so that we get a 6? See, these are perfect squares, so naturally we know that this will the last dividend will give you a 0. So either you can try 464 into 4 or 466 into 6. These two will be giving you a 6 in the units place. So once you try with 4, let's see, 4 4s are 16, carry 1, 2, 1756. No, it's very much small. So 6, 3, see, 466 into 6 is giving you 2796. So 6 over here, 6 over here. So 2796. So square root of 55696 is equal to 236. Alright. So for those who got the answer before I started the solution, you can put a star for yourself and tap your shoulders. And for those who could not get, please go through and make sure the further sums that you do on your own, you get the answers of each of them. Alright. So we got the square root of 55696 as 236. So I hope you are now very much clear with the process of finding square root using division method. I would refer everyone to go practice this method nicely, because this is a less time taking process and also less chances of getting error, because prime factorization, I've seen most of the time children making mistakes while they do the division. So this will take less time, and also this is a very interesting method as well. Alright, but the choice is always in your hands, whichever you feel like. But if in the question you are asked a particular method, then you have to follow the question and go for that particular method. If nothing is mentioned in the paper or in the question, then you can use the method that is you are comfortable with. But if any method is mentioned in the question, then you have to only go by that particular method. Even if your answer is correct, you might be having some penalty for not using the method that you have been asked for. Alright, so I hope this method is quite clear, and also the previous method. Hope you will go through more of sums and practice more sums based on this, and also come up with your doubts if you have any. The comment section is always open for you to post your doubts and your queries. And also, as I always say, if you really like the classes that I take up, please like the channel, comment your problems, your doubts, and also don't forget to subscribe the channel and share the channel. I will be very happy to come up with more of these topics that will be suiting your interest. See you very soon in the next video. Till then, bye.